The primary purpose of refrigeration is to eliminate the warm conditions under which destructive bacteria prosper and multiply, and by subjecting the bacteria to conditions of cold, to reduce their rate of activity and growth. The process of producing cold is the process of removing heat. Of the three effects of heat, refrigeration is chiefly concerned with two. The first effect, that of sensible heat, is one that causes a change in temperature as read in degrees on a thermometer. In this example, as heat is applied, the temperature of the water in the kettle rises up to 212 degrees Fahrenheit at sea level. At this point, the temperature remains constant, and the second effect, latent heat, is observed. The water changes state and becomes a vapor. Change of state may proceed in either of two directions. When a sufficient quantity of heat is absorbed by a solid, it passes into the liquid state. Upon absorbing more heat, the liquid evaporates and changes to a gas. When sufficient heat is withdrawn or released from the substance in its gaseous state, the gas condenses or changes back to a liquid. When more heat is withdrawn, the liquid freezes or returns to the solid state. For any substance, there are two distinct quantities of heat involved in changes of state. The first, latent heat of fusion, is the quantity of heat that must be absorbed by the substance in the solid state in order for it to change to a liquid. Or that must be removed from the liquid if it is to return to the solid state. The other quantity of heat, latent heat of vaporization, is that which must be absorbed by the substance in the liquid state in order for it to change to a gas, or that must be removed from the gas if it is to return to the liquid state. In mechanical refrigeration, it is the movement between liquid and gaseous states that is important. Absorption or release of latent heat does not alter the temperature of a substance while it is changing state. In this example, although the block of ice absorbs a certain quantity of heat as it melts, its temperature during melting remains constant at 32 degrees Fahrenheit throughout the change of state. Heat quantity is measured in British thermal units, or BTUs. A British thermal unit represents the quantity of heat required to raise the temperature of a pound of water 1 degree Fahrenheit. We know that when a liquid is heated to a certain temperature, it boils and changes to a gas. However, it is possible to cause the same liquid to boil at a lower temperature. This is done by controlling the pressure upon the liquid. The higher the pressure, the higher the boiling point temperature. The lower the pressure, the lower the boiling point temperature. It is through control of pressure that refrigerator temperatures are controlled. We know that heat will flow from the warmer to the cooler of two adjacent bodies, that the flow will be relatively fast while there is a large difference between the temperatures of the two bodies, and will become slower as this difference becomes smaller until it ceases when the temperatures of the two bodies have become equal. When a liquid changes to a gas, it absorbs heat which flows to it from its warmer surroundings. When these surroundings happen to be food in a refrigerator box, heat is withdrawn from it. That is, it is cooled or refrigerated. This is the rock-bottom basis of modern refrigeration. There are three methods by which transfer of heat from one place or body to another is accomplished. The first is conduction. When a flame is applied to one end of a metal bar, heat spreads through the metal, passing from molecule to molecule toward the cool end of the bar until the entire bar is hot. In the process known as convection, heat is carried along by the motion of a stream of gas or liquid whose function is similar to that of a conveyor belt. In conduction and convection, heat is transferred through or by matter. The process of radiation involves the direct transfer of heat in the form of waves, without need for a medium for the heat to move through. Refrigeration makes use of all three methods of heat transfer in removing heat from food items to a liquid cooling agent. Heat travels between the food and the cooling unit wall, both by means of radiation through direct waves and by means of convection through air circulation. The heat passes through the cooling unit wall to the liquid by conduction. The substance which soaks up heat during evaporation to create coolness is called a refrigerant. Its function is to remove heat from one place, leaving that place cool, and to discard this heat elsewhere while it is being changed back to a liquid. To produce refrigeration, all that is necessary is a refrigerant that functions in terms of the physical facts and processes already described. Refrigeration would be adequately achieved if we placed a liquid refrigerant in a box and provided an outlet for its escape following its change to a gas. However, at this point, several practical problems must be solved. To minimize the amount of outside heat that enters the refrigerated storage space, the walls of the box are filled with insulating material which does not absorb heat readily and is a poor heat conductor. A second practical consideration is the cost of the refrigerant. For economy, the refrigerant must be saved, stored, and returned as a liquid to be used again. And this process must be made automatic. This is the purpose behind all the electrical and mechanical devices which we identify with modern refrigerating systems.